Good afternoon, dear students. Today I will re-explain how to find the reference angles. Okay, the only thing that we need to know is where is that angle? I mean, at which quadrant? So here, this one is the first quadrant. This one is the second quadrant. This one is the third quadrant. And this one is the fourth quadrant. So the reference angle, for reference angles, we have two conditions. It has to be positive and acute angle. What does it mean, acute angle? So that means less than 90. Okay. So now let's take any angle in second, third, and fourth quadrant. The angles in the first quadrant, they will still the same. For example, if you have an angle 30, I say find the reference angle of 30. You're gonna say it's 30 itself. For 45, you're gonna say it is 45 itself. So we don't have any calculations for reference angle if the angle was in first quadrant. Now let's move to second and third. Second and third have the same rule. The rule is wherever you have an angle in second and third quadrant, you have to do this process. So 180 minus theta. Okay, and look, I'm putting the absolute value because if it is in the third quadrant, and the answer is going to be negative, and we want it to be positive, to be a reference angle. So now, if I asked find the reference angle for the angle 200, what you're going to do, just decide at which quadrant is 200. Well, it's less than 180 and greater than 90, so that means it's in the second, it's greater than 180, so that means it's in the third quadrant. So quad 3. Tamam? Now, what I will do, simply put an absolute value 180 minus the given angle. So here the result will be negative 20, and the absolute value of negative 20 is only 20. So that means the reference angle is 20. Look, it is positive and it is less than 90. Positive and less than 90. Okay, now let's take another example. If I gave you, for example, 150. Okay, if I said find the reference angle for 150, what you're gonna do, decide at which quadrant it is. It's less than 180, so that means it's in the second quadrant. Second quadrant, that means 180 minus 150. It is absolute value of 30, which is 30. Look, positive and acute. Okay, what if I had an angle in the fourth quadrant? For example, if I had 300. 300, as you know, it's in the fourth quadrant. So that means I won't use this formula. Okay, I won't use this formula anymore if my angle is in the fourth quadrant. Okay, why do I use this in second and third quadrant? Because if you have an angle, for example, if you have this angle, so that means you have only this much to reach the 180. Okay, what if I had an angle there? For example, this. Look. So if I had this angle. Now, look, this angle is that much far from 180. So that means if the angle is in the second or third quadrant, it's going to be a little bit far from 180. That's why I am using this formula. Okay, what about this? This, if you have an angle, for example, this. Okay. Now look, I have this much far from the whole loop. So that means I have this much far from 360. Here I had this much far from 180. That is why I depended on 180. Now this one is this much far from 360. So I have to use a formula that contains 360, which is absolute value again of 360 minus the given theta. When you, absolute value, when you use this, when your angle is in the fourth quadrant. Okay, now I have 300. So to find the reference angle, we will subtract 360, take away 300, so it's the absolute value of 60, which is 60. Look, it is um, positive and acute, okay, which is in the first quadrant. Now, one last thing is, notice all your angles are going this way. So here is anti-clockwise or counterclockwise. So does it make any difference if the function, if the angle is clockwise or anti-clockwise? Yes, but for the topic included in the exam, we the only the positive part, or only the anti-clockwise or counterclockwise is included in the exam. That's why we will postpone the negative part for the next lecture.